Hi folks, good morning. So today in this class we will be discussing about field programmable gate array architecture and its applications. I am Karthikeyan Chandrasekhar, working as an assistant professor, the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. A schematic representation of a field programmable gate array architecture is displayed. At the boundary, we have a block which we call it as input or output blocks. The input or output blocks comprises of multiplexer, various flip-flops and many logic gates. And each cell in the array represents CLB, configurable logic blocks, and these blocks is having a multiplexer, and we have different types of logic gates which is embedded on it, and the point which connects the neighboring cells are called as programmable interconnect, and this is also comprising many elements. So this is an FPGA architecture in an array format. Added to it, we have a BRAM, which is called it as block RAM, that comprises of SRAM, ROM and shift registers. And we have a unit called it as DSP, which is nothing but digital signal processing units. FPGA architecture mainly consists of the following blocks. The first one, CLB, configurable logic blocks. The second one, programmable interconnect. Third one, input block, output block. Fourth one, BRAM, which we call it as block RAM. And the last one, DSP units, digital signal processing units. First, logic block. It is a fundamental primary building block of FPGA technology. It consists of number one, LUT, lookup table. Second, MUX multiplexer, which is also called as a data selector. Third, flip-flop, which is a sequential circuit. LUT is an important element that can implement the logical functions like truth table, mux, which is used to act as a data selector between combination and sequential logic. Flip-flops is being used for sequential logic implementation. Sequential logic where my output depends on present input as well as the past input. The logic block again comprises of LUT lookup table as we discussed. So we have many input A, B, C, D, out of which one has been selected as an output, and that has been fed as an input to the multiplexer. And we have two signals, clock reset, which is connected to a flip-flop. As flip-flop is a sequential circuit, it will be triggered on only the clock has been supplied. The output of the flip-flop is again fed as another input to the multiplexer. Many input, only one output is a multiplexer concept with the help of select lines. So this is our internal configuration of CLB, configurable logic block. And LUT is the core of the FPGA architecture. It is designed to implement any Boolean function like x is equal to a plus b, y is equal to a dot b. Any Boolean function can be implemented. Inside the LUT, there are MUX multiplexers and the SRAM cells. So we could see here various SRAM cells from starting range from SRAM 0 to SRAM 7, and we have many multiplexers over it that contains the output based on the select lines. So it is used to implement KLUT inputs. The second one is a programmable interconnect. All the logic elements inside an FPGA are connected to an interconnect. Interconnect is nothing but a wire which connects internally within the CLB like LUT, multiplexers and flip-flop as we discussed in the previous slide. Again, your interconnect is going to act as a wire connection between the neighboring CLB cells in FPGA architecture in an array. The interconnect is a routing matrix comprises of programmable switches and wires. The routing elements provide a connection between input block and the output block, logic blocks, and between one CLB2 and the CLB. Third one, input output blocks. So it can be used for input and output both. The input and output part contains edge triggered D flip flop, edge triggered. So when there is a raising edge in the clock from 0 to 1, so which has both falling as well as raising. So negative and positive edge triggering, where positive edge triggering with respect to raise time from 0 to 1 and negative edge triggering is from 1 to 0 falling time of day flip-flops. The input-output block purpose is to provide the user interface from the outside world to the FPGA internal architecture. The IO block, again, it comprises certain elements. The first one, so FPGA is going to be connected with the PC with the help of some cable or with the input or output pin. So we have some delay element in which the output is required to fed as an input with some delay for the next successful purpose. A mux is providing a delayed input signal. A register is or latch is providing a register or latch output signal. A set reset line is for providing a set or reset signal. A decoder is to provide a signal responsive to the set or reset signal. An amplifier is provided for an amplified signal related with FPGA. The next one, block RAM, which is called as BRAM. It has embedded memory elements like RAM, ROM, or shift registers. So these elements are BRAMs, LUTs, and shift registers. It has been connected as a sequence of registers to each other, like a train of registers or chain or sequence. The purpose of this structure is to provide data reuse along a computational path, example filter. The last unit is a DSP unit, digital signal processing, where it is used to implement any Boolean expression. And the example of DSP48 is being provided over here, where we have an add or subtracted unit connected to a multiplier, and that will finally connect to add, subtract, accumulate engine. So this is our overall architecture of FPGA. Thank you.